I don't think this is probably going to be one of the most common techniques on the AP exam, but I just wanted to toss something out here. There is an integration technique that might be used in a couple of special cases. It comes up, I think it's in the Unit 6 progress check, there's one like this. So you're going to end up, it actually is based off the arctangent or the inverse tangent derivative rules. Remember, the derivative of the inverse tangent function is 1 over 1 plus x squared. Okay, so if I had the derivative of the inverse tangent of 5x, that would be 1 over 1 plus the input, or the inside function, squared. So that would be quantity 5x squared. Remember, you also have to multiply by the derivative of the inside function. So you'd have 5 over 1 plus 25x squared if you simplify the whole thing down. If I had something like this, that would be 1 over 1 plus the inside function squared. Okay, and then the derivative of the inside function is 1, and as a result, you don't have anything else coming from the chain rule there. If you multiply this out, that's x squared minus 8x plus 16, and then you're adding 1. And so another way that could be written is 1 over x squared minus 8x plus 17. Okay, what that implies is that there are occasionally some cases where you might have to integrate, take the integral of something. Notice the derivative of the inside function here is 2x minus 8. Okay, we would need a 2x minus 8 to be able to do this as a natural log. And so there's some cases where you might be able to take this and get back to something like this, all right? And the idea would be to try to get it into the form 1 over 1 plus something squared, okay? Well, if you did that, sorry, that's a 17 there. If you wrote this as 1 over 1 plus something squared, if I'm going to have a 17 there, if I'm going to put a 1 here, I would need to drop that to a 16. And then notice, if you factor that, that's the quantity x minus 4 times the quantity x minus 4. That's the quantity x minus 4 squared, okay? And as a result, you can see here that if you take the antiderivative, you look at it, you say, oh, it's 1 over 1 plus something squared. Oh, that follows the inverse tangent pattern, except instead of my inside function being an x, my inside function is an x minus 4. And then you can see you could go back to something that looks like that, okay? So let's try one that's, let's try one. So, and the challenge, if you're a BC student, of course, we know how to work with partial fractions, and so the question is, should you be using partial fractions, or should you be doing something like this? Again, I think partial fractions are much more likely to show up, but it's another strategy. AB people, you don't have to worry about partial fractions, so it would just be this if they give it to you. So let's say they ask you to find an integral of something like 6 over, let's do something like 6 over x squared, let's see here, 6 squared plus 4x plus 5, something like that, okay? So you look at that and you say, all right, I'm going to use a natural log. Uh-oh, derivative of the inside function is 2x plus 4. I don't have a 2x plus 4 up there. You know, we can't do it that way, okay? So then you say, well, okay, I can factor out a 6. There should be a dx here. I can factor out a 6. I've got a 1 up here, okay? And you say, well, Mr. Manker showed us this thing where we could kind of make it look like an inverse tangent, okay? Inverse tangent derivative, of course, is 1 over 1 plus the inside function squared. So we've got a 1 there, but we want to write it as 1 plus something else, okay? So I'm going to borrow 1 from this and take it down to a 4, okay? So I'll write this as 1 plus x squared plus 4x plus 4. Okay, 1 plus x squared plus 4x plus 4, okay? 1 over 1 plus something squared, okay? If this is going to work, when you factor this, and by the way, notice, this is the same thing as x squared plus 4x plus 5, okay? I just borrowed a 1 and brought it over there. This is only going to work if this factors as a perfect square, okay? That's the quantity x minus 2, sorry, x plus 2 times the quantity x plus 2. Which is the same thing as the quantity x plus 2 squared. So now you can see it follows the pattern of the inverse tangent derivative, 1 over 1 plus the inside function squared. Okay, so the antiderivative would be the arctangent of the inside function, okay? Derivative of the inside function's 1, so we don't have to counterbalance or anything like that. And we had a 6 out in front, okay? Now, on the AP progress check, I think it's unit 6, there's one, I think the denominator is negative. Okay, you don't want -1 minus x squared or something like that. So I think in that one you're going to have to factor a -1 out of the denominator first, and then you're just going to have a negative in front of your integral basically at the end. And your denominator will turn into something that you can write as 1 plus something squared. So again, do I think this is going to come up on the AP exam? No. Is it possible you're going to be in a college class and a professor goes through something like this and you can kind of be like, oh yeah, I've seen that before? Yeah, probably. Obviously, this would be a nice thing if you're going to stick it on a sheet of, kind of fringe stuff that, just last-ditch effort strategies. It might be something you want to kind of keep around. So anyway, that's the idea there, and you can decide how important you think it is.